Hello everyone, it's Wilson here. Today let's look at this derivative problem. I like this kind of function because it's a nice looking function here. As you can see, we have x raised to the sine x and then times cosine square of 3x. And that's actually a product. And one thing that we should pay attention to is that there is the x raised to the sine x here. So that's the base has the variable, and then in the exponent there is also the variable. So in this case, we are going to use logarithmic differentiation to find the derivative of this function. So to get started, we are going to first change this f of x into y, right? This is not doing anything to the problem. We are actually just changing the look. So this is really just cosmetic change. Okay, so now we have this function. What we are going to do is that we are going to take the natural log on both sides of this equation. So now it would be ln of y. So I'm going to use parentheses this time. So it's ln of y. Remember, this is not multiplication, it's ln of y, right? The y is being plugged into the ln function. So it's not ln times y. And then same thing for the right-hand side of the equation. So we have x sine x and then cosine square of 3x. Okay, so now we are going to use some log properties to simplify this expression here, to expand this log. So we are going to be getting ln of y, right? And then we are getting ln of x to the sine x. Now, because this is a product, so we are going to be adding ln of cosine square of 3x. So far, we are not doing any calculus. We are just doing algebra steps, right? So we are using the log property to expand the log into the sum of two logs, right? We expanded the product into the sum. And so the next step is to use another log property. That is to bring the exponent to the front of the log. Same thing here, we are going to do that. So we are going to be getting ln of y. And if we bring the sine function to the front, right? So then we are going to be getting sine of x, right? And then there is still the ln of x. Plus, now we also want to bring this square to the front, right? Because that square is actually applied to the cosine, and cosine is inside the log function, so we can bring the square to the front. So we are going to be getting the 2, and then ln of cosine, no more squares, so just cosine of 3x. Now the cosine function is entirely inside the natural log function. Okay, so now what is next? The next step is to start taking the derivative, because now we have no more exponents, and so that actually makes taking the derivative easier because we don't need to worry too much about the power rule and the chain rule anymore. We still got to do the chain rule, we still got to do the product rule, but the product rule that we're doing here is a lot simpler that we have to do it here. So what we are going to do is that we are going to take the derivative on for the whole equation. We're using implicit differentiation. We are differentiating the whole equation with respect to x. Okay, so let's continue. Well, actually, let me do the step right here. So if we take the derivative of ln of y, we are going to be getting 1 over y, right? And then because we are differentiating y with respect to x, then we are going to be getting dy dx, or we can simply just write y prime. Okay, and in fact, I should just point out that that's really just dy over dx. Remember, y is a function of x, right? So we have dy over dx, and then now we are going to start writing down the answer here. So we have, we use the product rule for this thing because there are two functions. One of them is the sine x, and then the other one is the ln of x, right? So let's take the derivative. When you differentiate the sine x, then you are going to be getting cosine x. And then the ln x is something that we do not touch. I'm suspecting that we may run out of space on the right side, so I'm just going to move everything to just slightly so that I may have more space. Okay, so next step, we are going to be differentiating the second function, and then we are just going to be copying the first function. So I'm going to be getting sine x right here. And then when we differentiate the ln of x, we are going to be getting 1 over x, right? 1 over x. Okay, so far so good. Then we're finished with this portion here. Now we got to take the derivative of this term. When we take the derivative of this term, the 2 doesn't really matter, and we are going to be differentiating the ln function, right? So it's going to be 2 times 1 over, okay, because it's the ln function. Now, what goes in the denominator? It's whatever that's inside the ln function that goes in the denominator. So that's cosine of 3x. But that's not finished yet. Now we need to multiply by the derivative of the inner function. So we are getting 3. And then, well, actually, we should say negative 3 cos sine 3x, right? Sine 3x. Yeah, the derivative of cosine is negative sine, and then also we need to multiply by the derivative of the inside, which is negative 3. This comes from this this 3 comes from the derivative of the 3x. This negative sign comes from the derivative of the cosine. So now we have all that. Yeah, so now I do have space right here. That's good. Okay, so it's a good idea to actually simplify this step a little bit. So we are going to be getting 1 over y times y prime. And then just clean up this whole expression right here. So we are getting cosine x ln of x, and then plus sine of x over x, and then minus. Why do we get the minus? There is a minus sign right here, so we get the minus. And then 2 times 3, we are going to be getting 6. And then in the numerator, we have sine of 3x. Okay, that's from here. And then in the denominator, we are getting the cosine of 3x, right? So cosine of 3x. Yeah, so now all we need to do is to multiply both sides by the y, right? So we get the y on both sides of the equation. So we are getting y prime is equal to y times the bracket of cosine x ln of x plus sine of x over x minus. Now you can see that that's sine over cosine, so we can turn it into just tangent. So 6 tangent, that's even cleaner. And then the brackets. Okay, and then what is y equal to? Y is really just our original function. So now we place the y with this original function, then we have the whole derivative. So y prime, okay, is x sine x cosine squared 3x, and then cosine x ln x plus sine of x. Yeah, that's a lot of stuff, right? So we have sine x over x, and then minus 6 times tangent of 3x. And that's all that. That's our final answer. It's a lot of stuff here. Okay? So that's it for this problem. If you like this video, please give me a like, subscribe my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this.